5, we'll take a look at factored form of a quadratic. So there'll be a link on Google Classroom that will take you to this investigation. There's a little check-in here. And then on this slide, what do you notice? We have 3 quadratics. The shape is the U-shaped graph, the parabola. And I want you to take a look at it, and what do you notice about these 3 graphs? Look at the equation, look at the graphs, look at anything else that you see in the graph, and is there anything that you notice about these graphs? And then you can share down here. So we're going to start by looking at the x-intercepts. The x-intercepts of the graph are where they cross the x-axis. And this graph has an equation of y equals x minus 2 times x plus 1. Can you tell me what the x-intercepts of the graph are? So if we take a look, the one on the left-hand side would be where x equals negative 1. And then, oops, I put negative 2. And on the right-hand side, it looks like we have x equals 2, because at 2, the graph crosses the x-axis. Let's take a look at another example. The equation of this graph is y equals x minus 8 times x minus 5. What are the x-intercepts of this graph? So again, we're looking where does the graph cross the x-axis, and here it would be at 5 and at 8. So we can say x equals 5, because where x is 5, it crosses the graph. And we can also say where x equals 8, because again, that is where our quadratic crosses the graph. So again, as we're doing these slides, you should be thinking about, all right, what's the relationship between this equation, which is in something called factored form, and the x-intercepts of the graph? So are we noticing a pattern here? A pattern that would help us make a prediction. So let's take a look at this one. The equation of this graph is y equals x minus 2 times x plus 3. What are the x-intercepts of the graph? And for this one, the first x-intercept on the left-hand side is x equals negative 3. And we also have an x-intercept at x equals 2. So by the third slide, hopefully you're starting to notice a pattern between this equation of a graph of this quadratic in factored form and the zeros, or the x-intercepts, they're also called zeros. All right, so look at this graph, specifically at the x-intercepts. Okay, so we've looked at 3 examples so far. Hopefully you've noticed a pattern. Can you make a prediction on what the equation of this graph is? Type it in below. So again, if we look at the previous problems, how does the equation relate to the x-intercepts? Would you be able to extend that knowledge and give me the equation of this graph right here? And if you type in or make the guess, y equals, well, one intercept is at negative 3. So we could put x plus 3. And then we have an x-intercept at 1. So x minus 1. All right, this would be my guess. I guess I don't need the equals or too many spaces there. But let's check it. Is this actually the equation of the graph? So on the next slide, I'm going to type in that same equation, and I want to check my work. So I said x plus 3 in the parentheses, and then x minus 1. And then if you take a look at this graph right here, does it match the previous graph? And you can say, yes, it does. We can even check the vertex. The vertex would be at negative 1, negative 4. Was that the vertex for this graph as well? Negative 1, negative, yep, so this is the same graph, and my prediction was correct. Okay, how about this one? The equation y equals x minus 4x plus 1 matches the graph. Where do the numbers in the equation show up on the graph? So this is really testing, did you know how to get this equation? I mean, what's the pattern that you noticed? And hopefully the pattern that you noticed is, if you're given this equation, that the x-intercepts are going to be the opposite of what's inside the parentheses. So the opposite of negative 4 would be positive 4, and that would show up as one of our x-intercepts. And then the opposite of the positive 1 is a negative 1, and that would be my other x-intercept. Okay, so how I might describe this as, I could say the x-intercepts are the opposite of what is in the, or I should say of the number in the parentheses. Okay, so consider these equations. Which equation will match this graph? So let's look for the x-intercepts. We have a negative 2 and a positive 5. And we talked about how in the pattern that we looked at, it's going to be the opposite. So the opposite of negative 2 is positive 2. So it's either the top or the bottom. And then the opposite of 1, 2, 3, 4, 5 is negative 5. So top or bottom. Okay, so what's the difference between the top and the bottom? One has no negative in front, and one has a negative in front. And if we take a look at, well, actually, you know what? You could graph this. If you were unsure, you could go ahead and graph and see. What does that negative do? You know, it's the top or the bottom. So let's say we didn't know which graph it was. I'm just going to open up a Desmos page, and let's try graphing these to see what they look like. Okay, so I'm going to try the positive one. So it was y equals x plus 2 minus 5 plus x minus 5. Okay, so yep, that's, okay, so then the question is, what does the negative do? Let's try that. Okay, x plus 2, x minus 5. Oh, so the negative turns it upside down. So it must be the first one, the positive one. So you can check your answer using Desmos. And to explain my thinking, well, I graphed it. So I graphed it, and the one with the negative in front was upside down. Okay. Explain how you could use this equation to find the x-intercepts. So the pattern is, you know what's in the parentheses, it's going to be the opposite. So the opposite of 3 is negative 3. The opposite of 4 is negative 4. Okay, so why does that work? Why are the x-intercepts the opposite of what's in the parentheses? And it has to do with the y value. The y value at the x-intercept is 0. So really we're finding, where does this equation equal 0? So I put that 0 in front. And now we can solve this equation for x. And so really what we're looking for here is, we have a number, x plus 2, times another number, x minus 4, and that number times another number equals 0. And there's this property called zero product property, which says, well, if either of these numbers that you multiply by is 0, the whole thing's 0, right? 0 times anything is 0. And so what we're going to do is we're going to solve for each part of the problem. And I want to show this. I'm going to escape out of here. Okay, I'm going to show this right here. So again, here was the equation that we're looking at. Y equals, whoops. Sorry, my iPad's kind of sticky here. Okay, so y equals, oops, I was on which slide? Okay, x plus 2, x minus 4. Okay, so again, I know that, here's my starting equation. I want to know where the x-intercepts are, so where the y value is 0. So we have 0 equals x plus 2 and x minus 4. Now these two, they're called factors because they multiply together. These two are different numbers. And again, if either of these numbers equals 0, then the whole thing is 0. 0 times anything is 0. So what I can do is I can break it into two problems. The first is x plus 2. What makes that 0? And then if I solve that, if I subtract 2 from each side, we would say, well, if we plugged in a negative 2, negative 2 plus 2 is 0, and 0 times whatever this number is 0. And I can do that over here too. Well, what makes this factor equal 0? And to get rid of a minus 4, we'll add 4. And so we would say, well, if x is 4, 4 minus 0 is 0, and 0 times whatever this number might be is also a 0. And so if you look at our answers here, notice they're the opposite of what we have in the parentheses. So negative 2 makes a positive 2, 0, and a positive 4 makes a negative 4, 0. So what we're finding, they're called the x-intercepts, but they're also called the zeros because this is where the y value is 0, and it makes the factor 0. We can see why it's the opposite, because it makes the factor equal 0, and the equation equals y, and we want to know when y equals 0. So if we go back to this right here, these are called zeros, x-intercepts. They're also called the roots of the graph, and we'll talk about that when we go over quadratic formula. Why are they also called the roots? But these x-intercepts are also called 0 because that's where the y value equals 0. And we use zero product property to say, hey, what makes x plus 2 equals 0? It's negative 2. And what makes x minus 4 equals 0 is positive 4. So these opposite numbers will make the whole thing 0. And that's what we want to find the x-intercept. So let's practice. All right, so here's one way of thinking about this. If we have two numbers, okay, so this is kind of just what I explained. If you have any two numbers that multiply to 0, one of them has to be 0, right? So again, if one of them is 0, the whole thing's 0. So then we solved it, so I kind of showed how I broke it down. And we know that what makes x plus 2 equals 0? It's negative 2. What makes x minus 4 equals 0? That's positive 4. And that's how we got the x-intercepts. It's the opposite of the numbers in the parentheses. Zero product property. Okay, so that's factored form of a quadratic, which just says if you have this thing in factored form, if you take the opposite of what's next to the x's, that makes the whole factor 0, which makes the equation equal 0, and that's what we're trying to solve. Okay, so let's do some examples, and then the rest of this is your assignment, but we might do some of them together. Okay, so it says adjust the equation to create 3 different parabolas that pass through the points. Okay, so so we can adjust these. We want them to pass through negative 4 and 4. Okay, so we want to know what would make a negative 4 0? It'd be a positive 4. So I'm going to change that to positive 4, and I'm going to change this to a negative 4. Oh, I'm sorry, it's not a 4, it's a 3. Okay, positive 3, so it should be a negative 3. Oh, now my right graph goes through the points. And you can take a look at the blue one then. Okay, so again, this negative 2 in front, that is not going to affect our zeros, but the negative 2 does make it go upside down, and it does make it skinnier, but let's make it go through the zeros. So the opposite of negative 4 is positive 4, so I'm going to make this one a positive 4. And I'm going to make this one a negative 3, and then it should pop through there, and it does. And our last one, the only thing different is that 1/5, and we can see the 1/5 makes it wider, and it's positive, so it's a U-shaped graph. And again, we'll change the factors so they're the opposite of the zeros of the x-intercepts. So we have x plus 4, x minus 3, and it will go through the zeros. Okay. I could have changed the numbers in front too, I guess. So I could have changed the negative 2 to like a negative 5, and we could see what happens. So you can change that number in front as well. But we did want it to go through the zeros, the points. All right, plot 5 parabolas, one through each set of colored points. When you're finished, press check my work. Okay, so this red one is a smiley face graph, or it's a U-shaped graph, so it's going right side up. And the zeros are negative 7, negative 5. Okay, so I need to do the opposite of that. So y equals x plus 7, x plus 5, and I can check it. Ooh, and I got that to work. All right, now the second one is upside down, so I know there's going to be a negative in front. Okay, what are the zeros? It looks like negative 4 and negative 2. So the opposite of negative 4 is 4, and the opposite of negative 2 is 2. Check my work, and it graphed it. Perfect. Let's do the green one. It's a smiley face graph, so no negative in front. And one of the zeros is at negative 1, so the opposite of negative 1 is positive 1. And the opposite of positive 1 is negative 1. Okay, so I'll keep going. I'll do one more. So the orange one, it looks like I have a 0 at positive 3 and positive 2. Okay, so the opposite of positive 2 is negative 2. Oh, I forgot my equal sign. And the other 0 is at 4, so the opposite of 4 is negative 4. And it's upside down. Okay, so I'll check my work. Oh, did it not graph? Oh, because I put an extra y here. Silly me. Okay, there we go. Okay, so the rest of the assignment, I think you can get pretty much through our knowledge of, this is Angry Birds, are the zeros. So this says press play to see what happens. Okay, so this is just showing you want to hit the Angry Bird, you win. So then on the next slide, you're actually going to adjust the equation so that it's going to hit the red dot. Change one number in this equation so the bird will go through the blue point. Okay, so I need to, okay, the zeros are at 1 and 8, so I'm going to play with this number. I want to make it skinnier, so I'll try 3. Nope. Or do I want to move it in? Maybe I want to move it in. Maybe I want to adjust the 0. I'm going to put -2 here. Ooh, that's closer. Can I adjust that? Let's see. Do like 2.5. Okay, what happens if I hit play here? Oh, then I do hit it. Okay, so you can adjust the zeros. I thought you just had to adjust the number in half. So I changed it so it would go through that point. I changed the 0 and I moved it. Okay. I'll do one more. Change one number in this equation so that the bird hits the pig and passes through the blue point. All right, so For sure, I'm changing the 0. So I want, instead of an 8 or a 10, I want to make that an 8. Oh, and look, it goes through the blue point as well. Okay. All right, so the rest of the assignment, you're going to play around with the equation, and you're going to see if you can hit the blue point and the piggy using what you know. And there's also some diamond problem practice because, again, we will be doing some factoring where you'll need to know how to do the diamond problems. Okay, so finish that for your assignment.